And indeed, just as Michelle said, I'm extremely proud to be one. I've got about 10 or 12 minutes or so to make the case that there has never been a better time in history to be an Australian botanist, and particularly an Australian taxonomist. I'm embarrassed a bit to be reprising our Prime Minister Malcolm Turnbull in saying that, but nevertheless I believe that it's true. It is an immensely exciting time, and we as a discipline, I must say, we have a lot to grumble about. The type of work that we engage in, the foundational work that comes with taxonomy and systematics, is not always appreciated. The bright and frothy stuff on the surface of science tends always to get the limelight and to get the citations and the Nobel Prizes, and tends often to understate the degree to which the bright and frothy and flashing lights is only possible when it's building on the foundational work that taxonomists and systematists do. So we sometimes have a tendency to be a little glum about the 21st century, and for good reason. I won't understate the reasons, but I think that there's also there are many, many reasons why, as I said, this is the best time to be one, and we're doing, and I think we're on the verge of some really quite extraordinary things. So today my plan is to look on the bright side, and I'll also in the talk, I think to some extent I'll refer to the next decades, to the sorts of things that I can see coming and that I can see us doing. The talk is a bit idiosyncratic, I think. I've decided in putting it together. It's very much my personal view of some of the things that I think are conceptually really interesting in what we do and what we will be doing in the next decades. So I won't really go into... I could have written a talk going into specifics, the way that we're planning to build an electronic flora for Australasia, the way that some of us are working towards a decadal plan, which will be a statement of the value of our discipline, and hopefully a statement of value which could lead to investment and turning those things around. But I'm not actually going to talk about specifics so much. I want to talk about some of the generalities. The first reason why it's utterly fantastic, I reckon, to be a taxonomist and a systematist these days is because of the tree of life. Theodore Dobzhansky in 1973 wrote an essay saying nothing in evolution makes sense. No, nothing in biology makes sense except in the context of evolution. I think we can actually clarify that a bit further. Nothing in biology makes sense except in the context of the history of life, which is phylogeny, and which we can put together by understanding the tree of life. And I certainly find, I teach second year plant diversity courses at UWA, and I basically give the students a cook's tour through the tree of life of green plants, telling stories along the way. And it's an immensely satisfying way of doing it, and students engage very well with that. The tree of life, resolving the tree of life, is utterly fantastic when you think about it. It's this amazingly synthetic view of the entire life of an entire planet that we are in the process of resolving. And really that's exactly what we've been doing all the way along, and it's what we are on an immensely accelerating curve. If one could somehow have a metric, it'd be interesting to think how to do this, a metric of the degree of resolution that we have of the tree of life, it would be an exponential growth curve. And we're on the really, as with all exponential growth curves, there's years and years and years where not much seems to happen, and then you get to the hockey stick part of it. We're right on that hockey stick part of it. Fabulous. The next thing on my list, and it's related to this in a sort of curious way, is the success of Linnaean architecture, or of Linnaean nomenclature rather. Michelle referred to the way that taxonomy and systematics look both backwards and forwards. We are an intensely historical discipline. I would argue that we have stronger links to the past than most other disciplines of science. Linnaeus invented his hierarchical classification system, 250 years ago? More than 250. It still works. That, to me, is one of the most astonishing facts of the last several centuries of research. When you think about it, the interesting thing is, so the hierarchical classification system is a way of representing a tree. A hierarchical classification is a tree. We've understood that ever since Aristotle. You've got families and then genera within families and species within genera. That's a tree. A hierarchical classification system as envisaged by Linnaeus and as developed by subsequent botanists isn't a very well resolved tree, but it's a tree nonetheless. An interesting thing happened with the advent of particularly DNA technologies from the 1960s and 70s, where there was a major challenge to the question of whether it is appropriate to envisage life as a tree or whether it's better to envisage it as a network, as a reticulation. Horizontal gene transfer was discovered. We all know about hybridization. These are all things that bugger up the tree. To what extent do they bugger up the tree? Is it better to think of life as a network or as a tree? And the answer is the challenge that we have had to the idea of life as a tree hasn't caused us to have to throw away Linnaean hierarchies. And that, to me, is actually a really, really neat thing. I've kept expecting that sometime we're going to have to throw away the last 2.5 centuries of work and start again. But we haven't. That's really something to be proud of. It's a great achievement. So simply the fact that life remains a tree and that the methods that we have and that we're increasingly developing for explaining the tree, that in itself is just great, I reckon. The exciting time now is that we have both the conceptual tools from phylogenetic theory and methods and the data from DNA to resolve that tree in ways that we could never have imagined that we could do. And because we appear to have one tree on Earth, we can go right back to the root and we can resolve it back to the three great groups, the bacteria, the archaea, the eukaryotes, right to the very, very tips of the tree and resolve things out extremely finely and in fine detail. I can't think of anything more exciting than that. The third thing that I think is fabulous is that we are engaged in the task of documenting life on Earth. Essentially, one way of looking at it is resolving the tree of life. And I reckon that we're going to get there. For a long time, we have sort of thought that this is an immense task and that we'll actually never get there, which I must say I found a sort of a depressing idea that, somehow we're engaged in some sort of glass bead game where we're just, doing stuff and it will never end. If you engage in something like that, I must say I don't really quite know the point of it, because if it's never going to finish, it's a bit hard to really get excited about where you're at, because you don't know where you're at because it never finishes. I think that we are actually reasonably close to having the tree resolved extremely well for many groups of organisms. That doesn't mean that we've finished and you can close down all the herbaria. As Michelle said, having that physical documentation that we base things on is tremendously important. It also doesn't mean that you can shut down taxonomy and systematics, because simply knowing the tree, having the tree resolved, having life documented, then becomes a starting point for asking the sorts of fabulous questions that were asked in one of our keynotes, our plenary lectures this morning. What can we do with it? How can we do stuff? How can we answer questions that we haven't even dreamed up yet? And I think that we're able to do exactly that. I make the bold claim, and I realise it's a bold and perhaps ridiculous claim, that we are actually close to documenting the tree of life, with one change, or one nuance, I think. When I said before that the Linnaean hierarchy has stood the test of time, I think that there is something which is going to break our model of taxonomy in a way that I actually think is really interesting. And that is that the Linnaean hierarchy is fit for purpose, or the Linnaean nomenclature, which is intimately bound up with the hierarchy, is fit for purpose for some things, such as naming plants and macroscopic animals, the sorts of things that we as humans engage with. It's actually not all that fit for purpose for identifying or for naming the vast numbers of microbes that we now know that we need to deal with. And I think in that sense we are on the exciting times of needing to develop a new system of nomenclature which is fit for purpose for that domain, while retaining the nomenclature that we have for the one that we're mostly involved with. The fourth thing, which I'll only touch on because it's obvious, we all know it, is the World Wide Web. The web makes everything possible to integrate and synthesize all of the things that I've just talked about. We can have such vast amounts of information at our fingertips. My children laugh at me every time when we're at a restaurant, we're having a conversation, and I pull my phone out and connect to the web to look up something or other, usually something obscure. But the fact that we can bring all these things together, phylogenies, nomenclature, all of the stories that are attached to organisms, and the questions that we will start answering through the web, is the thing that is another thing which to me is obviously extraordinarily exciting. And we live in a fabulously challenging time of having to synthesize these things through the web, and that's exciting. So, finishing up, I will reprise our erstwhile Prime Minister again. I think a good motto for taxonomy has got to be continuity with change. And while that is laughable for the Australian Liberal Party, I think it's actually a very good motto for us. Thanks very much.